Hello, Konstantin. Hello, Mike.
Hi, Konstantin. Hi, Caio.
Hello, Caio. Hello, Mike.
Thank you for joining us again.
Thank you too.
So, how long have you been an iOS developer?
I'm an iOS developer for the 3.5 years.
Awesome. How can we help you?
I have 4 questions. The first is about clean architecture diagram. I have some troubles with understanding that UI and database implementation unit in one layer in diagram, and what should be in entity layer also.
Right, UI database and entity. The clean architecture diagram, you mean this one, right?
Yes.
Onion.
The onion with layers. Also known as the onion architecture, ports and adapters, clean architecture. They are all very, very similar. And pretty much you want at the core of your application, you want the domain logic, like why your application exists. Right? It's the domain, the heart of your application. For example, if it's a banking system, in the heart of the application is everything that supports the banking to work, like current accounts, loans, and so on. If it's like an investment bank, you would have here like futures, options, stocks. Modeling what supports the business logic, the business rules.
This is logics, and it is not depend on UI
Yes.
databases.
That's correct.
Yeah, ideally it should not depend on UI or anything, because you should be able to deploy these in a web application, in a mobile application, in different kinds of applications with different user interfaces, with different persistence frameworks, with SQLite, with SQL Server, Postgres, CoreData, Realm, and so on. So you want to decouple the domain from frameworks. Those frameworks are volatile dependencies. You may change it for different reasons. You may change it for performance reasons, but not because there's a new type of account, right? Mm-hmm. So in the domain, you keep what is core to the business in the core domain. And then you also have supporting domains. For example, thinking about the banking application, you need to log in to your banking system, right? To authenticate yourself. But the bank doesn't exist because of authentication. It exists because of lending money, holding money, transferring money, and so on. This is the core specialty of a bank, their domain. But they need to have security layers. But those are subdomains to support the core domain.
Mm-hmm.
But a bank doesn't exist because of logging, right? It's just a security concern, for example. So in the core, in the domain, here you would have, as you mentioned, the entities, right? It's the entity layer. So different way of seeing it. Here you have like entities, aggregates, value objects. There are different types of models that represent why your application exists. What is its core domain, its core functionality, right?
Only models or models of in this diagrams we have use cases, the red circle, and should in entity layer in the core should be some, I don't know, services with logic, or it should be in red circle.
So in the core here, you may have domain services that represent some domain concepts that doesn't fit precisely in a model. But in the red layer, you have application-specific logic. So application logic, and in the core here, you have things that are more independent of application. For example, if you have like a current account, in a banking app, right? You can have an aggregate that represents a current account. What is a current account? It's a series of transactions, money in, money out, right?
Yep.
That's what it is, like your bank account. And then what is your current balance? Is the sum of all the money that came in and all the money that went out. And then you know your current balance, right? But it's a series of transactions. So you can model transactions, you can model the account as an aggregate, and you can model it just as pure structs or classes, not dependent on any framework or any application.
Yeah.
Foundation is can be here, depend on foundation.
Yeah.
It depends. If you don't want to depend on foundation, because foundation only works on Apple platforms, it's not 100% portable. Yeah. If you want to run it on Linux, you may not be able to use all the foundation types because it's not ported fully. Some basic types are cross-platform, like data, URL, and so on. So it depends on the system. If you want to be able to use the same code in, I don't know, Android, then you won't be able to.
Okay.
But if you're dealing with, no, this is an application for iOS platform only, then why not? Because Foundation is available in the platform.
Yeah.
Right, so that's okay.
I think I understand.
Yeah.
So you have here in the core the entities, and then in the outside you have the application specific logic. For example, you can have a service to get the current balance for the user, because you need to display this in the user interface. You can have a service that will fetch the entity from a database through an abstraction, and then talk to this entity to calculate what is the current balance, and then return it. So that's application-specific logic that will use the entities. There's a dependency here. The use cases will use the entities to provide application-specific logic.
And if I want to reuse my app logic, I reuse only entities. I don't reuse use cases, services, and controllers, presenters.
Yeah, usually, if you want to reuse logic, you put them into entities and aggregates. You move this logic to the core layer, and then you use it across applications. Usually, you don't reuse use cases or you don't use interactors because they're very specific for an application. Unless you're deploying, like, it's exactly the same application,
yeah,
but just with different UI on the Mac or on iOS and watchOS. Then you can probably reuse use cases because it's exactly the same application, just a different platform.
Exactly. And remember, use cases and services, they are agnostic of the delivery mechanism, right? So in this case, it will make sense to reuse them. Again, as Caio said, it's like everything remains the same, right? These components, they don't know, like the delivery mechanism, the UI, for example, or the web, right?
Yes.
Okay.
Makes sense. So start here in the core. The pure entities, aggregates that don't depend on any frameworks. They don't inherit from CoreData managed object. They don't inherit from any framework, any ORM, or anything like that. They're just pure structs, classes, just basic types.
Yeah.
Also no decodable, for example.
It depends. Why would you use decodable here?
Or how? What do you mean exactly?
Yeah, usually not. Usually you use decodable or encodable if you want to persist them to disk or pack them into JSON and send it through the web, right?
Yes, and that should be in gray.
They'll be around here, yeah. So here are the frameworks. Remember, frameworks, infrastructure adapters. So if you need to send an entity through a network request, you will pack and get the data, transform it to JSON, and send it to the web here, right? So here are the frameworks that will perform that for you, for example, URLSession is a framework, right? And you may use URLSession to send the data. But you don't want the entities converting themselves to JSON directly, because the JSON needs to have a very specific format, the way the backend service expects. But you don't want to couple your entities to a specific backend. So you probably do it somewhere else.
But can frameworks only be in a gray circle? Or, for example, frameworks are different, and maybe there are framework for presenters, I don't know. And can some layer, blue or red, also have its own frameworks as a dependency?
So here, in these two layers here, you don't want to depend on frameworks, right? It's recommended. There's no hard rule. You can, we're free to do whatever we want. But then maybe you have penalties for doing it in the future, right? If you need to change the framework, or if you need now to deploy in a different application that doesn't want to use the framework, then it's going to be hard. That's why proactively, it's recommended that these two layers here, the application logic and the core domain or the domain, is not coupled with specific frameworks.
That's why we use boundaries also in the course, if you've seen that, right? As protection from frameworks.
Yes. So let's say a use case needs to fetch something from a database. You will create some kind of repository protocol, like we created a feed store in the course, which is a kind of repository, but it's an interface only. It doesn't leak any details about CoreData, about Realm, about the file system. And then we show how to implement it differently in this layer here, in the blue layer. So the use case needs to fetch something from a database. So you define an interface with what the use case needs. In that case, we create the feed store. Then in another outer layer, the infrastructure adapter layer, you will implement that interface. And then here in the blue layer, you will talk to CoreData or with URLSession and so on. And that's why the outer layer here, they are frameworks. They're not your code, probably. Mm-hmm. Here it's Apple code, it's CoreData, it's Alamo Fire, URLSession. They are here. But since you don't want your application logic talking directly to it, and also the frameworks don't know about your logic because they are reusable. URLSession doesn't know about your logic. Realm doesn't know about your logic. CoreData doesn't know about your logic. You need an adapter layer, an infrastructure adapter layer that will bridge this communication. So you have a feed store
I think I understand it.
Protocol here, defined here. And then you have a CoreData feed store implementation here. And outside you have CoreData, which you don't own. It's someone else's code. It's a framework.
Yeah, I think that's it for this question.
And you mentioned UI and DB implementation. They are in the framework side because of that. Because it doesn't mean they are in the same module. Doesn't mean they are grouped together in the same folder or in the same project. It means that they are logically grouped as a framework that lives outside your application. And somehow you need to use it, but you don't want to couple your business logic with it.
Exactly.
Right? Because you can see this onion design architecture as just layers, right? So the infrastructure adapter implements the protocols or interfaces that the application logic needs and talks to frameworks to fulfill its job, like URLSession, SwiftUI, CoreData, the keychain, and so on. But it doesn't mean that everything is in one package, in one module. For example, you can separate per feature. If you have feature teams, like, one team is responsible for payments, the other team is responsible for, I don't know, imagine you are Uber, like you have payments, and then you have drivers, and then you have the driver app, and you have the client app, the riders app, and then you have Uber Eats, and then you have different applications, and then you can have feature teams, a team that is responsible just for the payment. And it's absolutely decoupled from other features as well. They can be deploy them independently. They can develop payments independently. And then they just package everything into one application and ship to the App Store. But they can work independently without getting in each other's way. You can also split. Instead of having all the infrastructure adapters in one module, you can separate into different modules. You can have an API infrastructure module, an iOS UI module that uses UIKit for feature 1. And then in feature 2, you have an iOS UI module that uses SwiftUI. And maybe the persistent for feature 1 uses CoreData, but the login uses the keychain. Doesn't mean they are in the same module.
Yeah.
You can decouple as needed by the project. And imagine that you can have many implementations of this layer here, of the adapters. For example, you can have the core, which is exactly the same, like the feed we implement. And then you have the APIs, the cache application logic. And in the outside, you can have different UI implementations. For the same application, you can have the AppKit implementation, the WatchKit implementation, the SwiftUI implementation, the UIKit implementation, but still using the same logic, core logic. And outside, you see the frameworks here: Firebase, URLSession, AppKit, SwiftUI, SQLite, Realm. Make sense?
Yes.
And you can separate as many layers as you need. You can imagine this onion, you start peeling it and like breaking it down. And if needed, you can separate the different modules. They don't need to be one thing. They could be all in one module.
Yeah.
But they can also be split into many modules as required. And you can also divide by features, right? Imagine that this is not the whole application, but this could be just a feature. And then the whole application is actually the composition of features. They are slices of this onion, right? Imagine you get a slice, a feature here, a feature there, and you compose. So imagine the same application, right? On iOS, you have 3 features. You have login, account, and feed. But on the watchOS, you cannot manage your account. You can only do login and feed. Thus, you compose these 3 features for that specific application. You have different composition routes for each application, for each platform if needed.
And maybe different frameworks in...
Absolutely. You can do whatever you want.
Yeah, you could use UIKit in iOS and SwiftUI on watchOS.
Yeah.
For example.
And the red layers, they remain the same, for instance.
It could, or it could be different. Yeah. But the core layer, you usually want to reuse the entities, the aggregates, the value objects that represent your domain.
Does it make sense?
Yes.
Awesome.
I think I understand the concept.
How many lectures are you in the program? We cover all of this, especially in the main module when we compose the features.
I think about half of program.
Yeah. Make sure you also watch Mentoring 6.
6?
Yeah, in the academy.
Okay.
Because it's about exactly this topic.
With Rodrigo.
Yeah, with Rodrigo.
Yeah. I think I can implement this diagram, but I don't understand how whole things works together.
You'll find out.
It's all in the program.
Yeah.
And I remember when the first time I saw this diagram as well, and it took me like maybe 5 years to figure out this whole thing,
Yeah.
When I saw from the first time I saw this from Uncle Bob until I figured out how to implement it, it took a long time. So in the program, we put everything together to lower the barrier for understanding this.
For understanding, yeah.
We break it down, especially in the main modules, break it down bit by bit to show how this whole thing works together and how you can break it down into separate modules or keep them all together. It's all in there. And don't forget to check Mentoring 6.
I will check
as well. Does it answer your question?
Yes. And I have another about unit tests. You in program you reuse tests for feed. store for multiple implementation, the same test and multiple implementations of storage. And this test don't depend on implementation detail. And where is the line between implementation detail and not implementation detail for tests? How deep we should test class with unit test? For example, should and if we change something from set to array, and should the unit test fail?
Right.
If the results are the same.
Yeah, I recommend you test the behavior of the class. So if you change from set to array, but the behavior is still the same, it's just a different implementation, the test should pass with no problem. You shouldn't have to update the test, which means that using a set or an array is an implementation detail.
Yes.
And maybe you're doing it for performance reasons. Maybe it's more performant to use a set in a specific case, and you have exactly the same behavior, it's just a different implementation. Now, if using a set changes the behavior, because now you have only unique values and then it changes, it breaks some assumptions you had before, then you should see a failing test. It should break because you changed the behavior.
Yeah.
And that's what we mean by testing the behavior and not the structure of the code. Thus, you can change the structure, you can optimize it to be more performant or make it clearer, make it easier to read the code without breaking the test. So behavior is what is the output of this function. Now, how it's processed, it doesn't matter. That's private. If it's using an array, a dictionary, a set, it shouldn't matter.
And this means that classes should be structured with some of input and some of output.
Yes. Not always, right? Sometimes if you have no output, it means that you performed some side effect in the system. Like updating a database may not give you an output. Just it succeeded or it failed. It just changed the state of the system, right?
Yes, I think with UIB controllers, in some cases, situation are the same because we can't get all informations in some cases.
Yeah, like when you press a button, you don't actually get a return. You don't get an output. But there's been a side effect, like change the state in the screen or transitioning to another screen. So there is a side effect rather than an output. Now, when you're testing stateful code like UIKit, you perform an action, like tap this button, and then you assert the side effect you expect, which is another screen is now the top view controller. Now, how that became the top view controller, it doesn't matter for the test point of view. Was it animated? Doesn't matter.
Yeah.
But if I have some private func in UIB controller, which is marked as opt-C for, I don't know, for some target with selector. And I can test it by performing a selector.
Yes.
Does it mean that I shouldn't do it because it is an implementation detail?
Yes, you shouldn't. Because if it is a selector of a button, for example, a target action, right? You add a target, self, selector, you pass an Objective-C method. Now, if you want to test what happens when you tap the button, you actually tap the button. In the test, you say button dot send actions for touch up inside. Now, when you send this action, if it's hooked up with a target action, some side effect will happen. And then you assert the side effect is correct, like presenting a new screen. So you're testing that tapping the button performs that, not the calling that method. Even though the button will call the method for you. But the button is the public interface. So instead of testing the private implementation of calling the method, you will test through the public interface. You test the behavior through the public interface. If there's a private method in your class, there must be a public method that you call. They will exercise the private method. Otherwise, the private method is just dead code, and you should remove it because it's never called. Because you can only call public methods from another module, which means that if you have some private method, some public method at some point will call it. Thus, you test this behavior through the public interface, the public method that you can invoke.
Okay, I think I also understand. What is it?
Because, for example, if you have your test like this, button.send actions for touch up and side, it works right now if you're using target action. But now there's a new API in UIKit, which are the UI actions. You can add a UI action to a button, which is a closure-based API since iOS 14. Now, if you were calling the method directly in your test, you have to update your test.
Yeah.
Because you're not calling a method anymore with target action. Now you are invoking a closure in the button. So by coupling your code with a private implementation detail, you make refactoring harder because you need to update two places, the production code and the test.
Yeah, I do it.
Yeah, ideally you want to decouple your test from the structure, because then you could refactor now the production code to use the new closure-based APIs without breaking the test.
Exactly.
That's the benefit.
That's why we create all these DSLs as well. In the program, you're going to notice that. I mean, in the persistence module, I'm sure you did already, but in the UI as well, like for example, hiding from the test the fact if it's like a table view or a collection view. Like all we care about is a list and that some feed items are shown, right? So that's like another way to hide the structure of your code from the tests and just assert the behavior.
And you mentioned also reusing tests. So in the program, we show that, where is it? Here. We have a use case that talks to a protocol, the feed store, right? A repository. Now, the use case talking through this interface, it doesn't know the implementation. It could be CoreData, it could be the realm, and so on. But the use case has some expectations on how the implementation should work. Thus, it created reusable specs. They are tests that will guarantee that the implementation fulfills the expectations of the use case. Now, any implementation, a web implementation needs to pass those tests. A CoreData implementation needs to pass those tests. But the tests are decoupled from the implementation, which means you can just pass any implementation and the test will validate if it fulfills the expectations of the use case. But as you are implementing CoreData, if there's something very specific to CoreData, you should also write tests for that behavior. For example, in CoreData, when you delete an object, if it has a relationship, you need to make sure you have a cascade relationship with that other model to make sure that when you delete the core entity, the aggregate, all the other child are also deleted from the database. But that's a CoreData implementation detail that I'm not going to put in my reusable specs, because not all implementations need to have this cascade relationship. Or threading as well, making sure that we are calling the context updates in the right queue. This is a CoreData specific detail that if you are test driving CoreData implementation, you should fulfill not just the use case expectations, but also the framework expectations. But the framework expectations are specific to a concrete implementation, like CoreData or Realm or an in-memory one. So the reusable ones should pass for all of them, but there are some test cases that you might have to write specifically to one implementation.
And tests are placed in a red circle.
So the reusable specs, what the use cases expects is provided here in this red circle in the test module, right? In the test target.
Okay.
This is what you asked, if the test lives here in the red circle.
Yes.
Yeah, but the tests usually live in a separate module,
Yeah.
right?
Yeah.
That belongs somehow to this layer, let's say, but it's a separate target. Production code and test code, they live in separate modules. And the reusable one could be in a reusable module that you can ship to your clients, and they have to validate their implementation. But logically, yeah, they belong somewhere here, close to the layer they are testing.
I think that's it.
So test the behavior through the public interface. Thus, you can refactor the implementation without breaking the tests. As long as you don't break the behavior, you're good to go. Use arrays, sets, dictionaries, and so on. Shouldn't matter.
For example, if I have a method with a completion handler, I also check what I receive in completion. And maybe, but if we have some spy in that test case, we also can check how many times some method was called. Is it an implementation detail or not?
It is enforcing that the behavior is correct, because that's usually a bug you see in applications when you call a completion handler more than once. Right? A completion handler means this is completed. It means once I call this once, it should never be called again. So you can add a test to guarantee that the completion handler is only called once, because that's a behavior you expect.
Exactly.
If you call it more than once, it may lead to unexpected behavior. I've seen this bug many times.
Yes.
Because you forgot, like you have a guard statement and you call completion, but you forget to return.
Yeah, and the other thing is it's not in your implementation detail because it's in your test, right? It's the spy that you assert that was called once or whatever number you want, right? So your production code doesn't change, right? You just increase the like how much you check your system, basically.
Yeah. Okay.
Yeah.
I think I understand the problem with my tests. Okay.
Again, like all these things, you're gonna see them in detail as you progress.
Yeah, I see, and I just want to ask about it to figure out how things works.
Awesome.
Okay. Can we go to another question?
Absolutely.
I want to also ask about the dependency injection.
Mhm.
If I assemble my app in main module and I have some feature modules, and in that modules, for example, I have screens, which is you have a controller with router, interactor, and services. To enable DI, I should mark the types as public, and my main module can access that types and assemble it to one screen. Should I mark types as public only for DI?
What would be the alternative?
I don't know alternative. No. For example, placed all types in one module, and they will be internal and can access to each other, have access.
So if you have a module that needs to use a type from another module, right? So you have a main module that will compose some other classes. Then the classes needs to be public, because a module can only access public types from other modules, right? So that's Otherwise, you wouldn't compile. But if you want to hide this type, if there's a reason like, no, I don't want to make it public. I don't want others to know about this concrete class because there are some details they shouldn't know about and so on. Yes, you can. You can hide this type. For example, you could provide a public interface. Let's say you need to create a store, like a public protocol store. Then you have a concrete implementation of it that can be private, like a private class CoreData store that implements that store. And you can provide a factory method, like a public factory method, public make store, and this will return the public type store. But internally, you will return a CoreData store. So this way you're still hiding, right, the concrete implementation. So you can have methods here that others cannot call. Only the methods that are public here can be called from other modules. And this way you can have, your whole composition could be private, all types could be private, and you can have only a method that returns a public type that hides all the implementation details. For example, you mentioned a view controller. In the program, we show how to create a public composer class, for example. Then you can have a method here. Static func make controller, like make the scene, right? Let's say make scene. What you can return here, instead of returning your concrete, like my controller, you can return just a public type. And UI view controller is already a public type, right? And here you instantiate whatever you need. You compose your view controller. And now your clients only know it's a view controller, but doesn't know what is the concrete type, concrete subclass. So you return a super type in the interface that is public, but you have a concrete subtype implementation that is private, if that's what you want to achieve. Otherwise, you make it public. No, Apple does this a lot with class clusters. Check out class clusters. Oops, class clusters.
It is about NS array with NS I array, or I don't know.
Yes, and NS array is an example because NS array is actually an abstract class, right? Every time you use a factory method, like start array with another array, or start array from a mutable array, or start array from a set, and so on, you get a different concrete type, which is private. You cannot instantiate that directly, but it provides factory methods that will return those concrete types. And if you use the debugger, when you create an NS array and you check the debugger, you're not actually talking to an NS array, but a private subclass, subtype of an NS array.
Yeah.
And they provide you factory methods, and they hide the private implementations from you. UI button used to be like this as well. That's why they used to say, do not subclass UI button, because when you create them, you may get a different type because of class clusters.
Okay, I understand. And also, if I want a composer to compose my view controller with some dependency, I can path it in as a parameter.
Yes.
To function, make thin, and use it.
Exactly. Dependency injection in the method. Yeah.
Let's say the view controller needs a dependency, but you don't want your composer creating this dependency. Then you pass it through the method here as a method injection. You pass to the factory.
Okay, that's good.
Awesome. Any other questions?
Yes, the last. About CI. In app with many modules, I don't want to run all unit tests for all modules when changes, for example, in PR, I have changes only for one module, and I want to run tests only for that module, unit tests.
Okay, so run tests only for, you mean modules or modules?
Modules.
Modules
Yeah.
that changed,
Yes.
right? Okay.
If there are any practices to implement it.
Yeah, ideally you should only test what changed. The problem is that many code bases is like this. If you change a module, you're afraid the other thing broke. Thus, you're always running all the tests all the time. But if you created a good separation in your modules in a way that you can change them independently without breaking each other, then, and you have the confidence, you can start just testing what changed. Now, if they are separated already in different modules, like physically in a different repository, every time you push to a different repository, you only run the test for that repository. But if they are in the same repository, like a monorepo, you have many modules in the same repository, then you don't get this for free. Xcode doesn't do that for you. But what you can do is you can create your own custom script that will check the git diff, and then you can see all the files that changed. And depending on your project structure, by the file hierarchy, depending on the folder where the file is in, you can infer which module it's in. So very simply, you can parse the git diff, what files changed, get their folders, infer the module, and only run the test with Xcode build. And you run Xcode build test, and you pass exactly the scheme for that module, and you only run tests on that module. And you can speed up a lot your tests and still have a monorepo. You don't need to separate in different repositories. But you need to create this script.
Okay.
Shouldn't be hard. It's a good exercise. I'm not sure. Maybe Fastlane provides you that. I don't know. Every time I did this was manually.
I see that that was done manually. I think maybe there are solutions for that.
Because it really depends on your project structure,
Yes.
To see like what kind of modules should run, what kind of scheme should you use for running the tests. So it really depends on it's very custom because it depends on your setup. That's why you probably need to create your custom script, but can be done. Shouldn't be hard. Yeah, that would be a good thing to do. If you trust that you can change modules in isolation without breaking others.
Yes.
Or maybe you can even group, say, well, when I change this module, I only need to run tests in 2 other modules rather than in 10, right? And then you can say, logically, you can create some relationships that you don't run all the tests, but you don't run only in one module, but maybe in 2 or 3.
Or maybe only unit test with some UI tests for this.
Yeah, but that's custom logic depending on your project. Can be done.
Okay. I think I haven't questions.
Awesome.
Did we answer all your questions?
Yes.
Fantastic.
Thank you.
All right. Thank you for joining us again.
Thank you too.
Thank you so much, Konstantin. Bye. Take care.
Take care. Bye.
Bye.
How to manage all these repositories? It doesn't need to be in separate repositories. If you separate every module in a different repository, then it's going to be hard. You can use something like Swift Package Manager, CocoaPods, but you need to deploy. Every tiny change needs to be deployed. That's why usually, if you can, keep them together, monorepo, one repository, will make your life much easier.
Mm-hmm.
Should every circle be in a different module? Doesn't need to be. It can be, but it doesn't need to. It depends how you want to organize your project. It depends on your team structure. If you have different feature teams, different teams working in the same code base, but in different parts of the application, it might be interesting to separate it so you can develop without getting in each other's way. So it can be, but doesn't need to. Could be everything in the same module, but just virtually separating them. It would require more discipline, not to increase the coupling, but can be done in one module. But then you're probably building the module and building everything in one go might slow down the builds and the tests. And then you start separating as needed.
Yeah.
For your needs, to solve your problems. There's no ultimate setup that works for everyone. So if you have modules in your code base, you separate your code in a bunch of modules, and you have utilities. What is the best way to reuse the code across the modules? Well, usually, the solution will be to create a shared utilities module. The problem is that every time one of the modules need a tiny change in a utility, you need to recompile and deploy all the other modules because it's a shared module. So try to avoid shared modules. Depending on the setup, the application can be even better than trying to share code. Now, oh my God, how dare you, Caio? The application is evil. Yes, but sometimes the cost of coupling is worse than the application. So it depends on the case. But there are cases where it's better to duplicate than to try to reuse. Why entities should not implement codable? It depends. It's not that it should not. If it's implementing codable, to be able to convert it to JSON, maybe it shouldn't, because the JSON schema is a backend detail.
Yeah, infrastructure.
And that's why. If you're using codable for something to support the domain, no problem. But if it's because of an infrastructure detail, it's best to not do it. What do you do instead? You do the conversion in the infrastructure adapters layer. Where is it? Here. So your entities will live here, and you will convert them to some kind of DTO, data transfer object, that only holds the data, and they can be packed into JSON, plist, XML, and so on.
Bye, y'all.
See ya.